This is our answer key video for the differentiation practice that I sent you. That's too big of a pen. Let's try this one out. Okay. So since this is a video, I'm going to go through it pretty quickly, and you're going to be able to rewind whenever you like. But I'm going to try to cut down the explaining and the talking and just go. So here we go. Number one, since I'm finding the equation to the tangent line of the graph, that was cubed at the point 2, 8, I am going to need to find the equation of that tangent line. So I know that I'm going to use point slope. I already know my y coordinate is 8. I already know my x coordinate is 2. That's going to be the equation of the tangent line. I just need to go find the slope of the tangent line. To find the slope of the tangent line, I need the derivative. This is chain rule. The 3 comes down. Recopy the base. Reduce the power by 1 times the derivative of the inner function. Then I'm going to plug in the point at which we are tangent, the x-coordinate, and that will tell me the slope of that particular tangent line. Simplify that, I get negative 12. That is the slope of the tangent line at the point 2, 8. So I can fill it into my equation, and there it is. That's the equation of the tangent line. Number 2 is simply just find the derivative. Oh, it says y. So find y prime for y equals. I've got one binomial times another binomial. So that's product rule. This part in here is my f, and this part over here is my g. So f prime is a chain rule. Recopy the base, reduce the power by 1 times the derivative of the base. That's my f prime times g plus f. Let me get rid of these guys. They're in the way. That was f times g prime, so that's product rule. The 3 comes down, recopy the base, reduce the power by 1 times the derivative of the base, or the inner function. I've got two terms now separated by the addition. I've got that term and that term. First term and the second term. So I'm going to clean up each term, meaning I'll multiply the monomials and bring them to the front, and I'll keep track of the other terms in any order is fine. Here I've got a 3 times a 5, so it's 15. Then that. The next step typically with product rule is to common factor. So I'm going to factor out a negative 3, a 2 minus 3x, and a 5x plus 1 squared. I see that that's the common factor in both terms. Remember, I've got a first term and a second term. So now it's times, big parentheses, I'm going to have two terms. So if I divide a negative 3 out of the first term, out of the negative 6, I get a 2. If I divide 2 minus 3x, one of them out of one of them, they cancel, I don't have any. I have 3 5x plus 1s, and I divide out 2 of them, so I'll have one of them left. Now if I take and divide a negative 3 out of the 15, I'll have a minus 5. So here's my second term. This was my first term, this is my second term. And then I'm going to have 2 minus 3x because I had 2 of them and I divided out 1 of them. This is all one big factor. So I leave my finished product rule in factored form, things times each other. Except this last factor I got to simplify. So I'm going to multiply the 2, multiply the negative 5, and collect like terms. So that's going to give me a 10x. And then over here where I multiply the negative 5 times that would give me a 15x. So I'm going to get a 25x. And then when I multiply the 2 times the 1, I'll get a 2. And a negative 5 times the 2 is a negative 10. So negative 10 plus the 2 should give me a minus or a negative 8. So that is my finished version. Number 3 says find f prime of x if f of x equals x to the 1/2 times 3x minus 1. Typically, you'd think product rule, f times g. But because the binomial is power of 1, I can just distribute this and avoid product rule here. So x to the 1/2 times 3x is 3x to the 3/2. I add the exponents. Remember that exponent there is like a 1. So I can call it 2/2 to add it to the 1/2. Then when I distribute x to the 1/2 times negative 1, it becomes minus 1 x to the 1/2. This is f of x. I just did distributive property. Now I can apply the power rule, so f prime of x is 9/2 x to the 1/2 minus 1/2 x to the negative 1/2. I don't like negative exponents, so I'll write this as 9 root x over 2. That's one way to write that first term. Minus 1 over 2 root x. I'll accept it here. That would be good if you stopped there. Number 4. Find the derivative of g of x equals x cubed over x squared plus 3 to the 3rd. This is a chain rule, so the outer function is x cubed. The inner function is x cubed over x squared plus 3. So I've got the 3 comes down, I recopy the inner function, reduce the power to 2. Now it's got to be times the derivative of the inner function, which is now a quotient rule. The top is f and the bottom is g. So quotient rule says f prime g. So f prime is 3x squared. G is x squared plus 3 minus f, which is x cubed, times g prime, which is 2x, all over g squared. So now I look at this for the simplification as 3 fractions times each other. So I'm going to multiply the numerators and then multiply the denominators. Those colors look too much like the same. And that's going to set my fraction. So I've got 3 times x to the 6th because it's x cubed squared. So I multiply those, power to a power, times 3x squared times x squared plus 3 minus 2x to the 4th. And then over x squared plus 3 to the 4th. Because I've got x squared plus 3 squared because of this guy. I have to square the bottom. And then a squared times another thing squared is to the 4th. The last thing I need to do is get in here and clean up that stuff. So I'm going to simplify it by distributing the 3x squared. So I get 3x to the 4th plus 9x squared minus 2x to the 4th. Typically you would be done here, but we do notice that inside here you could factor out an x squared.
This is last call for the giving tree. If you have a preference, please bring it down to the main office. It is going out tonight.
You can also combine these guys by adding them. And I can multiply this stuff out here. So it's going to be 3x to the 8th times x squared plus 9 over x squared plus 3 to the 4th. Number 5, it says find f double prime, but we're just going to find f prime. Sorry, I was just looking at the pages. I didn't realize there's pages. F prime of x. Find f prime of x if f of x equals x plus 3 over x minus 1. This is a quotient rule problem, so f prime of x is f prime, which is 1, times g minus f times g prime, which is 1, all over g squared. Simplifying the numerator gives me x minus 1 minus x minus 3. So x minus x is 0, so I get negative 4 over x minus 1 squared. Number 6. Find f prime if f of x is 1 over x. I would rewrite this as x to the negative 1. So f of x is x to the negative 1, because this is like a 1, so I bring it up and make it negative. This way I can apply power rule. And then I want to simplify because I don't want negative exponents. The 1, remember, the negative 1 has its own exponent of 1. So remember, it doesn't move with the x to the negative 2. The x is the thing that's to the negative 2, so only that moves to the bottom. Number 7, find the equation for the tangent line again. So the graph, negative 2x cubed, oh, not the squared, sorry. Negative 2x squared plus 2x plus 3 at the point 1, 3. So again, I'm going to use point slope form and say y minus 3 equals slope times x minus 1. And that'll be my answer. I just need to go find the slope of the tangent line. So the way I find that is with the derivative. This is a power rule 1. Then I want to evaluate the derivative at that point. So I plug in 1. That means evaluate, to plug it in. So then I get negative 4 plus 2. So my slope of the tangent line at that point is negative 2. So there's the equation of my tangent line. Number 8 says find f prime if f of x is x cubed minus sine of x plus the cube root of x to the 5th plus 2 over x cubed minus 8. This one's annoying because there's all the different types of rules in here, or many different types of rules. I am seeing if you can kind of go through each term one at a time. The nice thing is they're all separate terms. So each term can be done individually or independently, but first I'm going to get them ready to do the derivative. That's ready for power rule. That's ready for the sine rule. This one needs to be written as x to the 5/3 so I can apply power rule. The next one needs to be written as 2x to the negative 3 so I can apply power rule, and negative 8 is all set. So now, the first one's power rule, 3x squared. The next one is the derivative of sine is cosine. Since the angle is x, I could do times the derivative of what's inside, but that's just a 1, so we don't need to worry about chain rule there. This is a power rule as well. This one's a power rule as well. And the derivative constant is 0. I don't want any negative exponents. I can write this like this if I want. I could write it back in root form as well, but remember that because the 6 has its own exponent, it doesn't move to the bottom. And that'll do it. Thank you for watching.